Well, I'm happy to announce this is my first Blizzard bag. It's a great time to be alive. So let's talk about factoring. I know, you're rolling your eyes. Let me go over some basic things about factoring, and then I'm going to show you a method of factoring that I just learned that I think you're just going to go bananas for. When factoring a polynomial, there are some pre-steps you should always go through first. One, make sure you write the terms in descending order with respect to one of the variables. That means the exponents should go from bigger to smaller as you go left to right. Step 2, make sure the leading coefficient is positive. If it's not, you can still do the problem, but it's much easier if it's positive. Then the first real step, whether you have 4 terms, or 2 terms, or 3 terms, is to factor out the GCF. Now I'm assuming that you know those things, so I'm not going to focus on those. We are going to focus on trinomials today. In the past, I have forced you, against your will, to split the middle term and factor by grouping. But boy, do I have something else for you today. You're just going to love it. It's called the Australian method. Let's just jump right into an example. Let's say that we have 10x squared plus 23x plus 12. And we're supposed to factor it. Going through our pre-steps, pre-step 1, write the terms in descending order with respect to the exponents. It's already done. We went to a 2, to a 1, and the next to the 0. Second pre-step, make sure that the leading coefficient is positive. Also done. Then the first real step, factor out the greatest common factor. In this case, the GCF is 1, so we don't have to do that. So here's how the Australian method works. I tell you, I'm just so giddy. I feel like a schoolboy right now. We're going to jump right into 2 binomials. That's right, we are not splitting the middle term. Take the lead coefficient, which is a 10, put that in the first spot of each of these parentheses. We're then going to take the x squared in the first term, and we're going to divide that up into each of the parentheses. So we have a 10x and a 10x. Now I know what you're thinking. This will never work. How can a 10x times a 10x become a 10x squared? You are very savvy because it can't. But you would agree that x times x is x squared. 10 times 10 is 100, which is 10 times more than we need it to be. Using the Australian method, we're going to put 10 down under. Now, we are not 10 times more than we should be because we're dividing by a 10. Once again, algebraically, we have an extra 10 in here that we're multiplying by. We're also dividing by a 10, so they're going to cancel out. So what's going to go in these other blank spots here and here? Well, you do this how you would traditionally do a trinomial. I also learned a new method to organize your work for this. It's called the MAN method. M-A-N. M stands for, what are you multiplying? Well, you're multiplying the lead coefficient times the constant to get 120. We need 2 numbers that multiply to 120. A stands for add. You are trying to add 2 numbers to get the middle coefficient, which is a 23. N stands for, what are the numbers that are going to work? Well, let's say that you can't think of a pair of numbers that multiply to get 120 and add to get 23 quickly. Well, let's just make a list of numbers. Start out with a number 1. 1 times 120 is 120. Does it have to be 23? Certainly doesn't. How about 2 times 60? Doesn't add up. 3 goes into 120 40 times. Doesn't add up. 4 goes into it 30 times. Doesn't add up. 5 goes into it 24 times. Doesn't that have to be 23? We're getting closer. 6 goes 20 times. Doesn't add up. 8 goes 15 times. That does add to 23. So in each binomial, we're going to put the 2 numbers that work which are the 8 and the 15. Doesn't matter which one you put where. I'm going to put plus 8 and plus 15. Now we're not done yet because we shouldn't have a fraction when we're done. What is the GCF of the first group? Well, the GCF of this first binomial is a 2, leaving us with a 5x plus 4. GCF of the second binomial is a 5, leaving us with a 2x plus 3. This is awesome. I am so excited. We end up with a 2 times a 5 on the top and a times 10 on the bottom. The Australian method is going to make the 2 times 5, which is 10, cancel with the 10 on the bottom, and we get these two binomials, 5x plus 4 and 2x plus 3. Done! The Australian method, because we put a number down under. Let's do a couple more. Factor by the Australian method. So our pre-steps, we want our terms in descending order, and we want the lead coefficient positive. I'm going to rewrite this as 5x squared plus 19x plus 12. We're going to look for a GCF. In this case, the GCF is 1, so we're going to ignore that. The Australian method says we can go right into our binomials, take the lead coefficient with one of the x's, and put that in the first spot of each. The x's come from the fact that x times x is x squared. The 5's come from the lead coefficient. Now once again, what's the mistake here? Well, it's not a mistake, but what's happening here that's going to give us the wrong answer? 5 times 5 is 25, but it's supposed to be 5. We're multiplying by 1 5 too many. So we put a little 5 down under to cancel out the fact that we have an extra 5. I'm telling you, this Australian method is the bomb. So to continue this, let's use the little man method. Man organization, I should say. It's not really a method. We need two numbers that multiply to get 5 times 12, which is 60. We need the same two numbers to add to get 19. And what could those numbers be? Well, I think that you'll find out pretty quickly those numbers are 4 and 15. 4 times 15 is 60. 4 plus 15 is 19. You put one of those in one of the binomials, one in the other. It doesn't matter which is which. In the second binomial, there's a GCF of 5. How convenient. Because we were dividing by 5. In fact, we had put the 5 down under. Australia! Which gives us the binomial 5x plus 4 and x plus 3. 'Tis factored. Let me show you one more of the Australian method. In this case, our terms are in descending order. The lead coefficient is not positive, and there's also a GCF. We're going to factor a negative 4 out of each of these terms, giving us 4x squared plus 15x minus 25. Australian method, bring down the GCF, we make two binomials. Put the lead coefficient in the first spot of each binomial, break the x squared apart evenly, so we got 4x and 4x. Now what's the problem with this? Well, 4x times 4x is not 4x squared, it's 16x squared. So to counteract it, we're going to divide by a 4. We're going to put a 4 down under. So to figure out what our integers are going to be at the end of our binomials, we are going to organize our work in a manly method. M stands for what are we multiplying? We're multiplying a 4 times a negative 25, which is negative 100. A stands for what we're adding. We have to add the same two numbers to get 15. So what numbers can we multiply to get negative 100 and add to get 15? If you know the answer right away, throw them into your binomials. Let's say that you're not great at this, so just make an organized list. Negative 1 times 100, negative 100. Negative 2 times 50 is 48. Well, I'm sorry, it's negative 100. When you add them, you get negative 48. 3 doesn't go into 100, 4 does. And negative 4 goes 25 times. Add those, you get 21. Negative 5 goes 20 times. Add those, you get 15. Put the -5 in one of your binomials, the +20 in another. Then look at each binomial. Is there a GCF here other than 1? No. Second binomial, GCF is a 4. Huh, convenient. Factor the 4 out, you're left with an x plus 5. Bring the other items down. Conveniently, but not coincidentally, the 4 that we had put down under cancels out, and this factors to a -4 times a 4x minus 5 times an x plus 5. Your Blizzard Bag assignment is to factor 15 of these problems using the Australian method. The assignment will be posted on the same page that you found this video. Have a great snow day. And why don't you put another shrimp on the barbie?